this lesson, we will look at Unit 6, Section 6.1, Slope of a Line. In this lesson, you will learn how to determine the slope of a line segment by measuring or calculating the rise and the run. And you will look at how to classify the slope of a line segment. In previous grades, you explored different types of linear relations, and we did this especially in Unit 5. And we sketched different graphs of linear relations using tables of values, but this is your first introduction to slope. So first of all, let's just review what rate of change would be. So rate of change was determined in Unit 5 by calculating the change in the independent and the dependent variables. So what you have to keep in mind here is going to extend on the terminology rate of change, and rate of change from here on out will be known as the slope of a line. Slope is a measure of how one quantity changes with respect to the other. Slope is a popular terminology used in Science 1206, and you can look at the picture on the right hand side that looks at a roof. So slope describes the steepness of a line, how sharp it increases, or how fast something will decrease. The slope of a line, slope of a roof, anything that describes the shape of an object, whether it would be increasing or decreasing, be a constant horizontal line or a vertical line, will all have some type of slope. So there are two ways to determine the slope of a line. The first method is determining the slope of a line when you are given a graph. When you are given a graph, you are going to use the rise divided by the run method, where you will choose 2 points on the line, connect the points by forming a 90-degree right triangle. Once you do this, the rise is the vertical distance between the 2 points, so as you're going up or down, and the run is the horizontal distance between the 2 points, so we're going across. So in the example that you're given, we are going a rise of 3 and a run of 2, which makes it 3 divided by 2. However, it will be negative since the line is decreasing and sloping down. Method 2 is to determine the slope of a line given 2 coordinate points. So you're not necessarily always given a graph. There might be 2 points given. For an example, you could have 1 and 2 and 4 and 3. So once you have this, you're going to use the slope formula, which is the difference in the dependent variable, y2 subtract y1, so the y values of your coordinate points, and you're going to divide that by the difference of your independent variable, x2 subtract x1. So when we have this, the line passes through the points x1, y1, and a second point x2, y2. So what you have to do here is to subtract your y values and then divide it by the difference of your x values. Especially when you're doing this method, it is important to label your coordinate points x1, y1 and x2, y2. You don't want to get them confused because you have to move in the same direction. So if you go y2 subtract y1, you will do x2 subtract x1. So when we want to classify the line or to classify slope, there are 4 different types. First, a positive slope. When a line segment goes up to the right, both x and y increase. Both the rise and the run are positive, so the slope of the line segment is positive. So once the graph starts from the left and increases to the right, it is going to be a positive slope. 2, negative slope. When a line segment goes down to the right, x increases and y decreases. The rise is negative and the run is positive, so the slope of the segment is negative. When you look at the graph itself, if it starts from the left and decreases to the right, the slope is negative. 3. Zero slope. For a horizontal line segment, the change in y is 0 and x increases. The rise is 0 and the run is positive. So any horizontal line segment has a 0 slope. As you can see here from the rise divided by the rise will be 0, and of course we can have, it doesn't matter what the run would be, so in this case it would be 1, 2, 3, 4, 5, 6 if you look at it that way, but there is no rise, so since there is no rise, slope will be 0 no matter what. So any horizontal line will have a 0 slope. And the last type of line is undefined slope. For the vertical line segment, y increases and the change is x is 0. The rise is positive and the run is 0. So any vertical line segment has a slope that is undefined because it doesn't matter how many units the rise will be, the run will always be 0. And we know from our mathematical knowledge that we cannot divide by 0, so this will result in an undefined answer. In summary, the definition of a slope of a line is a measure of its rate of change, which could be in two different ways, rise over its run, or you can use the slope formula on the right hand side, y2 subtract y1 divided by x2 subtract x1. And when we want to classify the slope, there are 4 different ways. It could be positive, negative, 0, or undefined. Determining the slope of a line is going to come in very handy when we have to write the equation of a linear function, and we will look at that in the next few lessons.